Installing a 6-position transfer box allows you to safely switch between utility power and generator power during an outage. This narration outlines the steps involved in connecting a transfer box to an existing service panel. Safety is paramount. Always disconnect power to the service panel before beginning any electrical work and consult with a qualified electrician if you are not comfortable performing these tasks yourself. First, you'll need the following materials: a 6-position transfer box, a 30-amp double-pole circuit breaker for the main generator connection, 6 30-amp branch circuit breakers for the individual circuits you want to power, 12 American wire gauge THHN wire in black, red, white, and green conduit and fittings as needed, a screwdriver, and pliers. Now let's move on to the installation steps. Step 1 involves installing the transfer box. Mount the transfer box in an accessible location near the service panel. Connect the main feed from the utility to the line terminals on the transfer box. Then connect the main feed from the generator to the generator terminals on the transfer box. Step 2 covers installing the main circuit breaker. Within the service panel, install the double-pole 30-amp circuit breaker in an unused slot. Connect the power lead from the main generator connection on the transfer box to the line side of this circuit breaker. Connect the load side of the circuit breaker to the main bus bar in the service panel. Step 3 details installing the branch circuit breakers. Install the 6 30-amp branch circuit breakers in the service panel, allocating one for each of the circuits you intend to power from the generator. Connect the power leads from the individual circuit connections on the transfer box to the line side of their respective branch circuit breakers. Connect the load side of each branch circuit breaker to the appropriate circuit terminals within the service panel. Step 4 focuses on connecting the neutral and ground wires. Connect the white neutral wires originating from both the utility and generator feed to the neutral bus bar inside the service panel. Likewise, connect the green ground wires from both the utility and generator feed to the ground bus bar in the service panel. Step 5 addresses wiring the interlock mechanism. The transfer box incorporates an interlock mechanism designed to prevent simultaneous connection to both the utility and the generator, enhancing safety. Connect the interlock wire extending from the transfer box to the designated interlock terminals located on the 30-amp double-pole circuit breaker. Step 6 involves testing the system. Once all connections are made, start the generator. Verify that the circuits connected to the transfer box are indeed receiving power from the generator. Then, switch the transfer box to the utility position and confirm that the circuits are now operating using utility power. Regarding wire sizing, 12 American wire gauge wire is suggested here for a 30-amp circuit. Always consult local electrical codes, such as the National Electrical Code, NEC, which provides detailed tables for wire sizing based on amperage and insulation type. For example, NEC Table 310.15. The 16 provides ampacity ratings for various wire types. Ensure your wiring is compliant with these standards. Circuit breaker selection is also important. The 30-amp double-pole breaker and the 6 30-amp single-pole breakers need to be underwritten as laboratories, all listed and suitable for the voltage in your system, typically 120 volts or 240 volts. Make sure the AIC, ampere interrupting capacity, rating of the breakers matches or exceeds the available fault current at your service panel. Conduit selection depends on your local code and the installation environment. Common types include rigid metal conduit, RMC, electrical metallic tubing, EMT, and flexible metal conduit. Choose a conduit that provides adequate protection for the wires and meets all applicable codes. Grounding is critical for safety. The grounding system should comply with NEC Article 250. Ensure proper connection to a grounding electrode system, such as a ground rod or water pipe. The ground wire should be sized according to NEC Table 250.122. Interlock mechanisms are essential safety features. They prevent backfeeding, which is when the generator sends power back into the utility grid. This can be dangerous for utility workers and can damage equipment. The interlock ensures that only one power source, either the utility or the generator, can be connected at a time. When connecting wires, use proper wiring techniques. Strip the insulation carefully to avoid nicking the wire. Use appropriate wire connectors, such as wire nuts or crimp-on connectors. Ensure that all connections are tight and secure. Labeling is important for future maintenance. Label all wires and connections clearly so that you can easily identify them later. Use a permanent marker or label maker to create clear and durable labels. Testing the system thoroughly after installation is crucial. Use a multimeter to check voltages and currents. Verify that all circuits are operating correctly and that there are no shorts or ground faults. The transfer switch provides a safe and convenient way to switch between utility power and generator power. It isolates the generator from the utility grid, preventing backfeeding and ensuring the safety of utility workers. The 6-position transfer switch allows you to select which circuits you want to power from the generator. This can be useful for prioritizing essential loads such as refrigerators, lights, and medical equipment. When selecting a transfer switch, choose one that is rated for the appropriate voltage and amperage. The switch should also be UL listed and comply with all applicable codes. Maintenance is essential for ensuring the long-term reliability of the transfer switch. Periodically inspect the switch for any signs of damage or wear. Tighten any loose connections and clean any dirt or debris. Also, test the switch regularly to ensure that it is functioning correctly. If you are not comfortable performing these tasks yourself, hire a qualified electrician to do it for you. Understanding basic electrical principles is essential for working with electrical systems. Voltage is the electrical potential difference between 2 points. Current is the flow of electrical charge. Resistance is the opposition to the flow of current. Ohm's law states that voltage equals current times resistance. Power is the rate at which electrical energy is transferred. It is calculated by multiplying voltage by current. Safety precautions should always be followed when working with electricity. Wear appropriate personal protective equipment, such as safety glasses and rubber gloves. Work in a dry environment and avoid contact with water. Disconnect power to the circuit before working on it. If you are not sure how to do something safely, consult with a qualified electrician. Understanding the NEC, National Electrical Code, is crucial for electrical work. The NEC is a comprehensive set of standards for electrical installations. It covers everything from wire sizing to grounding to overcurrent protection. Complying with the NEC is essential for ensuring the safety and reliability of electrical systems. Local codes and regulations may also apply. These codes may be more stringent than the NEC and may address specific local conditions. Always check with your local authorities to determine which codes and regulations apply to your project. Electrical permits may be required for certain types of electrical work. Check with your local authorities to determine whether a permit is required for your project. Obtaining a permit ensures that your work will be inspected and approved by a qualified electrical inspector. Ground fault circuit interrupters, GFCIs, are important safety devices. They protect against electric shock by detecting ground faults. GFCIs should be installed in areas where there is a risk of contact with water, such as bathrooms, kitchens, and outdoor outlets. Arc fault circuit interrupters, AFCIs, are another important safety device. They protect against fires caused by arc faults. AFCIs should be installed in bedrooms and other areas where there is a risk of fire. Surge protection is important for protecting electronic equipment from damage caused by voltage surges. Surge protectors should be installed at the service panel and at individual outlets. Uninterruptible power supplies, UPSs, provide backup power in the event of a power outage. UPS are often used to protect computers and other critical equipment. Generators provide backup power during power outages. Generators can be portable or permanently installed. When using a generator, it is important to follow all safety precautions. Proper wiring techniques are essential for ensuring the safety and reliability of electrical systems. Use appropriate wire connectors and ensure that all connections are tight and secure. Avoid overstripping wires, as this can weaken the connection. When working with stranded wire, twist the strands together before inserting them into the connector. Labeling wires and connections is important for future maintenance. Use a permanent marker or label maker to create clear and durable labels. Include the circuit number, voltage, and amperage on the label. The electrical testing is essential for verifying the safety and reliability of electrical systems. Use a multimeter to check voltages, currents, and resistances. Perform insulation resistance tests to check for ground faults. Perform ground impedance tests to verify the integrity of the grounding system. Electrical troubleshooting involves identifying and correcting electrical problems. Start by visually inspecting the system for any signs of damage or loose connections. Use a multimeter to check voltages and currents. Consult with a qualified electrician if you are not able to resolve the problem yourself. Electrical safety is paramount. Always disconnect power to the circuit before working on it. Wear appropriate personal protective equipment such as safety glasses and rubber gloves. Work in a dry environment and avoid contact with water. If you're not sure how to do something safely, consult with a qualified electrician. This information is for educational purposes only. Consult with a qualified electrician for specific guidance on your project.